around 6 months for them to get there, or actually 3.5 months. And then once they get there, they're going to spend some time actually turning on all the instruments, making sure that they work properly, that they're getting the data back, and that they understand it. And then it's around 6 months to when we get that science data flowing.
All right. Thank you for those questions. Keep sending them. Hashtag AskNASA across our social media platforms. And now, some quick facts about the third mission flying today. NASA's Carruthers Geocorona Observatory is about the size of a small couch and is as heavy as a full-size refrigerator. It will study our planet's exosphere, and studying this outer layer of Earth's atmosphere will help us forecast space weather, understand how atmospheres change over time, and even trace the history of our planet's water.
The goals of the Carruthers Geocorona Observatory are to study the nature and origin of Earth's exosphere and how it evolves over time.
The exosphere itself is the uppermost layer of the Earth's atmosphere. It's comprised almost entirely of atomic hydrogen. This is the lightest chemical species in existence, and it floats away, essentially, evaporates off of the top of the atmosphere. And when the sun shines on these atoms, they essentially scatter it off into all directions, and so it glows like a gigantic halo around the Earth. And so that's called the geocorona, that fuzzy halo of light that's given off by those exospheric atoms.
Many times we think of the transition between the atmosphere and space as being this very abrupt boundary where at one altitude you've got atmosphere and the next altitude you have space. But in reality, this transition is much more gradual and can extend over thousands of kilometers. By imaging the geocorona, we can actually answer fundamental questions about the size of the exosphere, the structure of the exosphere, and how it changes over time. And all of this in response to the input from the sun.
And what you're seeing now is a live look at the University of California, Berkeley's Space Sciences Lab Mission Operations Center. This is where Carruthers mission managers are anxiously awaiting liftoff and will monitor the spacecraft throughout its mission.
It's a little early there.
Not yet. They're there. They're taking a little break. We'll take a little break too, a little bit, but there they are in that, or will be in that room. Now, but the Carruthers principal investigator is actually here with us. This is Laura Waldrop from the University of Illinois. It's really great to have you here.
My pleasure. Very excited.
So the geocorona, part of the Earth's exosphere that glows, why does it play such a critical role in helping us to understand space weather?
Well, you know, the exosphere plays a vital role in